Right. Okay, so we are looking at this one, and once again, as I said, we are looking at a concept of implicit differentiation. So what is implicit differentiation? It is a form of differentiation where y is not ordinarily the subject of the equation. Derivative is to be found. So at this point, we have this equation. So now we apply the operator ddx on both sides of the equation we have been given. And if we do that, we have ddx is actually the same as ddx of 3. Right, so yeah, so you have that. You have that. That's fine. Right, so yeah, just take note of that. Take note of that. Okay, my pen sometimes jumps a little bit, but yeah, I'm gonna do it. Right, gonna be fine, gonna be fine, gonna be fine. All right. Right, I was writing here, and then now obviously we have ddx, and we have 3. So you'll find the derivative of x squared. What's the derivative of x squared? Is only 2x. We found the derivative of y cubed, but y cubed is y. The variable is y, so it becomes 3y squared. Then you put a dy dx minus 2. So now here at this point, you can do d. You can put d dx of 2y. Okay, I'm just doing this on paper. The derivative of the constant 3 is 0. We have 2x plus 4. This one is 3y squared dy dx. And then we put minus the dy. And then you have 2y, which is dy dx equals 0. Okay, so this is 2x plus 3y squared dy dx minus. Okay, I've just shown with a y term that we can do the differentiation in a way that we put the dy, and it's the same thing as the ddx. But what we note is sort of that through the cancellation method, the cancellation law, it is actually the same as the ddx in the previous equation. In which case, we're able to see, therefore, the derivative of 2y is the same as just minus 2 dy dx, and this result becomes identically 0, in which case we pull out the common factor dy dx, which is then the same as 3y squared minus 2 is the same as minus 2x. And therefore, this is the same as what? Okay, it is the same as what? Right, so it is the same as the following. So it is basically the same as dy dx is the same as minus 2x, which is all divided by 3y squared minus 2. Okay, that becomes the derivative. And it's exactly the same, obviously, as what they obtained here. Right, the next thing is now we want to find the slope of the tangent. So which means that we shall therefore evaluate these derivatives. So now this derivative can also be written as something is the same as y primed of x, which equals this. Right, so the next thing that we do here, we do what? Right, we evaluate the slope. So which means we can evaluate this like this. So we can write y primed evaluated at the x value. What is the x value here? Right, what is the x value there? Right, so we can see therefore at this point x is this, y start. So you can see that x is exactly what? It's exactly 2, which is minus 2 into x. X is 2 divided by 3. What is y? Y is 1. You square that, minus 2. And therefore, what is this? As a consequence, it is the same as exactly -4. You divide by what? You divide by 1 because it's 3 minus 2 in the denominator of the expression. The denominator of the expression. And therefore, the result is 4 negative. This result is -4, which is exactly what they got. But obviously, at this point, we have something to remember. What do we remember at this point? Right, we remember at this point that we want to find this, and therefore the tangent is a straight line that passes through a point. It passes through the point 2, 1, through the point 2, 1. So, which means, therefore, we come here and we do the following, right? So, the point is 2, 1, and what is the formula? Is y minus y1, which is the slope into x minus x1. So, which means that it is y minus, so this one is x1, y1, which means y1 is 1. The slope is -4 into x minus x1 is 2, which means it is y equals -4x plus 8 plus 1, which means y is -4x plus 9. So this is exactly the slope of the equation of the tangent. Okay, this is the equation of the tangent. Please think about it and make sure you understand. Okay, so equation of the tangent to the function given. Okay, how different is it from what they got? All right, so they wrote the answer like this. And then now it is exactly, if you look at it very carefully, it is exactly like this one here. This step, that step where they left things. Right, it is exactly like that because I just uploaded a study guide. So it's exactly like that one there, but we can just simplify it because it's the equation of the tangent, of the tangent line. Right, of the tangent. Obviously, a tangent is a line at this point. Okay, right. There was another question you sent to me, logarithmic differentiation. I need to just remember what page that was. It was unit 4 still, but now you had to look for something. What page is that one, Dylan? The other one, is that one of the logarithmic differentiation thing? Okay, you're going to other things here. Okay, I can hear that the network is not the best. That's fine. Okay, since the network is not the best, you'll get the recording. Okay, you'll get the recording in a few minutes. So you'll have I know. Okay, yeah, that's okay because yeah, the network is not the best, so I'm not getting the kind of um voice quality. All right, okay, it's just before this. That's okay. So here is logarithmic differentiation. Here it is. Right. So for example, this is the picture you sent to me. Okay, even if the video is not clear or the sound quality is not the best, okay, you will be able to see the recording is perfect. The recording is always perfect, so you'll get the recording. So just forgive me because sometimes you are failed by the network, and the ESCOM, sometimes it tempers with our towers and everything else. Okay, but now we know something. What do we know? We know that we have f of x, which is this, and therefore we have this. Right, so let's discuss the idea of a function in that form. Right, so at this point, we're going to discuss this function. What is the function? The function is f of x equals g of x raised to h of x. Right, so now if this is the function, we need to find something. We need to find the derivative of this. Right, to find the derivative of this, we need to use the log. So we use what we call logarithmic. Logarithmic what? Differentiation. What is logarithmic differentiation? So you use the natural log on the left. You apply the natural log on the right. which means it is the ln of f of x, which is the same as h of x as the ln of g. So now you can have exactly this step here. So it's exactly this step here they've written here. It's exactly this one. Okay, now just take note of that. Take note of that. So now we want to find f primed, if this is the case. Let's find f primed. Right, so let's look at this example. Okay, they looked at that example. So to find the derivative of that, the derivative. So let's look at the example. So the example is going to be, for instance, if you have been given f of x. F of x is the square root of x raised to the square root of x. Well, right, we apply the natural log on the left and the natural log on the right, which is f. Okay, so we continue now. We find the derivative of this. Right, so we differentiate both sides of this. If you differentiate both sides of this, what do we obtain? So we're going to get ddx. ddx of the ln of f of x, which is the same as ddx of the right-hand side. Okay. Or now this is exactly 1 over f of x times f primed. Okay, now here you find the derivative of the square root of x. What is the derivative of the square root of x? Right, so the derivative of the square root of x is actually the same as 1 over 2 the square root of x. Right, and then you use the product rule because it's a product of two functions. So since the product of two functions, you leave one function uninterrupted. So you leave the natural log of x plus the square root of x, and you find the derivative of the natural log. The derivative of the natural, how do you differentiate natural log? You always say 1 over the function times the derivative of the times the derivative of the square root of x. So at this point, so we have this 1 over this one. So which is 1 over. And then here you have the natural log of x. Okay. Plus, okay, so you have the square root of x and square root of x, they cancel out, giving us a 1. What is the derivative of the square root of x? Well, it's 1 over 2 the square root of x. Okay, we want to find what? We want to find f primed. So to find f primed, we sort of cross multiply, and this one is going to go to the other side. So you have this one, f, which is 1 over 2 the square root of x. The natural log of this plus 1 over 2 the square root of x. Right, so we have this one, f prime of x. What is this one? What is f? F is the function f of x is the square root of x raised to the power that, the square root of x, which is divided by, now this is the square root of x and this is that, right? So you can write like that, right? So you can write 1, and then here you can write this one. And then here you can write 1 over 2. It's correct. So this is the answer. This is the answer. This one is the answer. Okay, this is the derivative that is wanted. Okay, so obviously you can see at this point, it is exactly this one here. It's exactly this. It's exactly this because you can see there is 1 over 2 the square of x, which is the last thing we have got. The last thing we have got here. And then you can see this one here, which is 1 over 2 the square root, the ln. And then outside is the square root that. Okay, if the network is bad, please do not worry. And that is the result. What do they do now to just simplify that? At this point, you can pull out a common factor. What is the common factor? Right, so the common factor can be seen as follows. So it is f primed, which is the square root of x raised to this. You pull out 1 over 2 the square root of x. Okay, it's a common factor. You pull it out, and then you are left with 1. Right, you are left with 1, and then you have the square root of x like this. Right, so this is what you get. Right, so after you got this, this is exactly the answer. Right, but you can write it exactly like the way they did, like the way they wrote it here. So the way they did, if the network is bad, please do not worry much because you're going to get the recording. So this is that, which is divided by 2 the square root of x. And then you have 1 plus the ln of the square root of x. 1 plus the ln of the square root of x. So you have this. So, right. So this is exactly the answer. This is exactly the what? The answer. And that is the result there. Okay. Think about this. Any question, Dylan? The network was bad sometimes. I could not hear you.
No. Yeah, I do understand this one and the way it has been done.
Okay.
You know what I failed? I failed when it comes to number 70 or 71. That's where
71.
I got stuck.
Here. Here. This one. Okay, the 71 that is here. Okay. This, okay. 71, this one.
Yes.
All right. Yeah, do you want us to do it?
70.
70.
Yeah, please.
70 or 71. Which one?
Whichever one you can do is fine.
I can do both anyway. Okay, so that's fine because my power the power might leave at 10. Let me just check again. The power might leave at 10. What time is your power leaving? Just I'm curious. Okay. Okay, we're gonna just do that now. Do you have the load shedding schedule next to you? Okay. Right. So I'm expecting the power to leave from 10 to 12. Okay, but now let's look at, so any minute I might be cut. Right. Let's look at maybe we can look at number 770. 70. Right. Okay, let's look at 70. Right, where we still have the power. So this is exactly x to the power ln x plus 7x to the power 2 over 3. Okay, we want to find the derivative of this one. Right, to find the derivative of this one, there are a couple of things you need to consider. Right, so, but now the trickiest part is how to find the derivative of this part here. Right, so you'll have to use substitution. Right. So you need to realize that f primed of x will be the same as ddx. ddx of x to the power ln x plus the derivative of this one, ddx of 7, x to the power 2 over 3. Okay, so it is f primed of x, which is the same as, yes, ddx of x to the power ln x. I can hear you very well now. Okay, right, so this is 7, and then you bring down the 2 over 3, and then you subtract 1 from that. So if you subtract 1 from that, what is 2 over 3 minus 1? 2 over 3 minus 1. So we can see the result. Okay, right, so we have this. Now, to find the derivative of this part, I want to mention, because the trick here, it is x raised to a function of x. So you need to use the e, okay? So you need to use the e. And then you put e, the ln of this. You put the ln of the function exactly like that. Right, okay? And then what is 7 by Okay. All right. So this is 14. Okay, I'm not yet load shedding. Not yet
Okay.
load shedding. Okay, I'm not yet load shedding. Are you still there?
Yes, I'm here. I'm
Okay,
here.
thank you. Yeah, because I just got a message that yeah. Okay, yeah, but yeah. Okay, but the recording is gonna be perfect if there are interferences, you know. And then what is 2 over 3 minus 1? Is minus 1/3. Okay. Right. So right. So the little trick was just in differentiating the other part, in differentiating
Yeah.
yes, this E
Can
part.
you hear me?
Okay. Right. So differentiating E,
Can you talk about
yes. Please come
Can
again.
you talk about the differentiating part of? Can you talk about differentiating the x ln one x?
Yes, the X, the power in X, we can talk about that because that is what I'm actually looking at. So at the top, you would have ln X, you bring it down because it's an exponent. And then now you have also ln X. Okay.
Okay.
So you can close here. You can close here. 14 over 3, X to the minus 1 over 3. Okay, so right. What is this? Dylan, so is DDX. Right, so this is X, and then at the top you have X, you square that. Right. Plus, this is one way to do it. 14 over 3. I'm just looking at one way to do it, and then we can any method is going to be equivalent to this one. Okay, so you have F primed. Okay, now how to differentiate E? Any exponential function of X can be differentiated. E is always the same. So to differentiate E, you always have, you keep it the same, all right? E to the power anything is always e to the power that, and then you multiply by the derivative of the top, okay, like this. And then plus 14 over 3x to the minus 1/3. So what is this? So this is F primed. So what is the derivative of that? So it is 2 ln x. Then you multiply by the derivative of ln x, which is x. 1 over x. 1 over x. Right. And then now you have the e to the ln x is still the same. Plus 14 over 3. This is the answer, but it can be written in many ways. Okay, note that we found the derivative. Okay, we still have power here. Maybe we're lucky that the power is not gone yet. Okay, right. So, but look at how we found the derivative of this one here. The derivative of this one, we use the chain rule, and we find how do you find the derivative of this? Okay, my power is gone. Okay. Thanks a lot, then, Dylan. We'll talk. Goodbye.